Okay, we are moving on to lesson 6. Now, lesson 6 is still 7.1 because we are talking about exponential growth and decay functions. However, this time, our goal is to be able to look at a word problem and pick out the bits and pieces of the word problem to help us solve for our exponential growth or decay function. So after this, there is a worksheet for you to complete on exponential growth and decay word problems. So let's get into it. The first one is modeling exponential growth. You can model exponential growth with a constant percent increase over specific time periods using the following function. A of t equals a times 1 plus r to the t. Now here's a breakdown of what each of those mean. So a of t is the amount after t time periods. So for example, let's say at the beginning of quarantine, right, we had a certain amount of internet usage, home internet usage. I want to know how much the internet usage has increased during quarantine. So a of t is after the time period. So let's say I wanted to measure it right now. That would be what you are solving for, the amount of internet usage right now. Whereas A is the initial amount. So I would find the amount at the very beginning and then compare it to right now. R is the percent of increase. So that's saying it's increasing at a certain percentage every single day as more and more people get on lockdown. And then we have our growth factor of 1 plus r. So you're going to take that r value, which you're going to write as a decimal, not a percent, and then you're going to add 1 to that for the growth factor. Now, growth factor, the amount of internet usage is growing. That tells you that you need to use this formula. However, we also have exponential decay. So you can model exponential decay with a constant percent decrease over specific time periods using the following function. A of t equals a times 1 minus r to the t. So the only difference between this equation and the previous equation is that it's no longer 1 plus r. It is 1 minus r. Okay, and all of them mean the exact same thing, except for now, r is the percent of decrease. All right, let's go over an example. Our first example says, in 2006, there was 1.020 billion people worldwide using the internet. At that time, the number of users was growing by 19.5% annually. Write a model to estimate the number of people using the internet in the year 2016. First thing that you are going to want to do is identify if it's either exponential growth or decay. And normally in your problem, it's going to straight up tell you, right? It says the number of users was growing. That tells me that this is going to be an exponential growth function. Which means I want to use the equation a of t equals a times 1 plus r to the t. So now what we're going to do is we're going to identify all of those various pieces that we expressed here. First thing, a of t. Remember, that's your amount after a specific time period. Well, that's what we're trying to find out. Write a model to estimate the number of people using the internet in the year 2016. So we don't know that yet. That is what we are solving for. Okay, next is our initial amount. So that is a large number. You do not have to plug in a large number. Just create it into a decimal. So I'm going to write it as 1.020 billion. Okay, after A, we want to find our rate. Now our rate here, it says it's growing by 19.5% annually. But like I said before, we do not want to keep that as a percentage, so we're going to change it into a decimal. In order to do that, all you have to do is take 19.5 and divide it by 100. And we're going to end up getting 0.195. Okay, after that, 1 plus r. So all I'm doing is adding 1 to 0.195, so I get 1.195. And then last thing that we need is time. So it says in 2006, we had that amount of people. And then it's asking us for how many we're going to have in 2016. Well, what's the difference between 2006 and 2016? It's 10 years. So our time is going to be 10. Now all we have to do is plug it into our equation. So we're solving for a of t. Okay, that equals a, so 1.020 times 1 plus r, so 1.195 raised to the t, and t here is 10. So now what we can do is we can grab our calculators and plug that into our calculator. So we've got 1.020 times 1.195, and then we're going to raise that to the 10th power. And we end up getting 6.06. And remember, that is in billions. So our answer here, after 10 years, so t is 10, we are going to have 6.06 billion people using the internet. And that is going to be our final answer. All right, let's move on to problem 2. It says the pressure of a car tire with a bent rim is 34.7 pounds per inches squared at the start of a road trip. It decreases about 3% for each mile driven due to a leaky seal. Estimate the air pressure of a tire after 15 miles. First step, let's identify whether or not this is exponential growth or decay. Again, it tells you right here, it says it decreases about 3%. So decrease tells me that it's going to be exponential decay. Which means that we are going to use the formula a of t equals a times 1 minus r to the t. Okay, and we're going to do the exact same thing that we did last time. Identify all of our different variables that we need here. So we have a of t, so that's the amount after t time. So in this case, again, we don't know what that is. That is what we are solving for. So we're going to put a question mark there. Okay, next is our initial amount. So it says the pressure of a car tire with a bent rim is 34.7 pounds per inches squared. So that is our initial amount before it starts decreasing. Now after that is our rate. Okay, it says it decreases about 3% for each mile driven. So 3%, which again we're going to change into decimals. So 3 divided by 100 gets me 0.03. All right, now it's decay, so it's going to be 1 minus r. So 1 minus 0.03 is going to get me 0.97. And then t, time. So in this case, time is miles, right? It says estimate the air pressure of the tire after 15 miles. So clearly we're starting at 0 miles. So at 0 miles, it's 34.7 pounds per inches squared. And we want to find out what it is after 15 miles. All right, now that we have all of this information here, let's go ahead and plug it into our formula. So a of t, so the amount after 15 miles, equals our initial amount of 34.7 times 1 minus r, which we got to be 0.97, raised to t, which in this case is 15. All right, let's go back to our calculator and plug that in. So we've got 34.7 times 0.97 raised to the 15th. All right, and that gets me about 21.97. So our answer here is the amount of pressure in the tire or the car tire after 15 miles is going to be 27.97 pounds per inches squared. And that is our final answer there. One more example. So it says the first U.S. Census was conducted in 1790. At that time, the population was 3,929,214. Since then, the U.S. population has grown by approximately 2.03% annually. Two parts to this. The first part is write an equation using the information above. Okay, and then after that, they said identify the population for the year 1850. So the first part, they're not giving us a time, right? They're just saying that at the beginning, this is what the original population is. Write me an equation so that I could say any year, and all you have to do is plug that in to solve. So we're going to do the same thing here. First of all, exponential growth or decay. Here it says, since then, the U.S. population has grown, which tells me that it's going to be growth, meaning I'm going to use the equation A of t equals A times 1 plus r to the t. All right, let's identify all of our various pieces here. So we've got A of t. We don't know what that is, especially because we don't even know what the time is. So we can't say an amount after t time because we don't know what that is. However, we do know what our initial amount is, and again, it is a large number, so I'm going to shorten it, and I'm going to say that it is 3.93 million. Okay, our rate is it's growing by 2.03% annually. So divide that by 100 to get my decimal, and I've got 0.0203. And then 1 plus r, since it's growth, gets me 1.0203. And then our last part, t. Again, we don't know what t is. They haven't given us a year quite yet. Right now, we're just getting the general formula. So let's plug it in. We've got A of t equals A, our initial amount, so 3.93 million, times 1 plus r, so 1.0203, raised to t. Don't know what t is, so we're going to keep it as a variable. B says identify the population for the year 1850. Okay, well, if we're starting at 1790 and ending at 1850, that is 60 years. So we can say that t is 60. And we already have our equation here. So A of 60 equals 3.93 times 1.0203 raised to the t, which we can now replace with 60. All right, and when we plug this into our calculator, we are going to end up getting 13.12 million people. Okay? All right, so now that we've gone over some of these questions, go ahead and complete the assignment and let me know if you have any questions.